we've seen sequences and that general term, and that we can surely use to get a sequence, but sometimes that could be a lot of calculation, and it might just be easier to express a sequence in terms of its previous members, if at all possible. When we do that, we define the sequence using recursion or recursively, and that leads to this recursive form of a sequence. All this means is that we define the nth term, the general term, using one or more of the terms earlier in the sequence. Okay, and additionally, we have to define what the first term or terms are so that we're able to generate the entire list. Okay, so for example, we have the sequence A, B, C, and D here. The sequence A, we know it starts by or starts with 5. So I'm just going to write that down here at the bottom. So it's going to be 5, and then I'm going to generate the first 5 terms. Okay, so what this is saying is that to get the nth term, okay, it's equal to 3 times, okay, a sub n minus 1. Okay, this is the previous term, okay, and minus 4. So some books I've seen use this as the next and the now. Okay, so to get the next version, you need to take 3 times whatever you have now minus 4. Okay, so that is to say, if I want A2, I need to do 3 times what I have now, 5 minus 4. Okay, and so then that's 15 minus 4 is 11. So then the next term is 11. Okay, to get the next term in the sequence A3, you have to take 3 times what I had now, 11 minus 4. So 33 minus 4 is 29. All right, and so then again we do the next one, and to get A4 I would do 3 times what I have now, 29 minus 4, which is going to be 83. Okay, and now you can see the numbers are getting a little large, and we might need to get out a calculator to do this. And so then the next one I'm going to do 3 times 83, and I'm not going to write this out, minus 4 to get 245. Okay, so this would be the first 5 terms of that sequence. All right, for sequence BN, I want you to pause the video, try it out, and resume when you're ready to see the solution. And here's what I got. Okay, and so again, I'm generating the next term based on the previous one. Okay, and that pattern continues. So -3 goes in there, and then the result 2 goes in there, and finally 1 goes in there. Okay. All right, couple more examples. I'm going to get you started on sequence D, and then I'll just kind of finish the solution for you, and you can finish it on your own too. So I know D1 is this, and then to get D2, I have to take 2 divided by the previous one. So this again is the next value, and then this is the now. Okay, so I need to take 2 over 4. I get 1/2. D3 is going to be 2 over half, which is 4. Okay, and then D4 is going to be 2 over 4. Okay, you start to see the pattern here, is 1/2. And then D5 is 2 over 1/2, which is 4. So this one is going to kind of bounce back between 4 and 1/2. So it'd be 4, 1/2, 4, 1/2, 4. Okay, kind of an interesting sequence. Okay, the last sequence here is a famous recursively defined sequence. But now this one, you have 2 starting values, so you actually know that it starts out as 1 and 1, and then we have the job of finding the next 3 terms. And so what this is saying is that to get the next term, okay, what you're going to do is take the previous term, the now term, okay, plus the previous, okay. So you have to take 2 things and add them together to get the next thing. So you take 1 plus 1 to get the next one, so that's going to be 2, and then now I take 1 and 2 to get 3, and then 2 and 3 to get 5, and you might recognize this sequence as the Fibonacci sequence. Okay, so just know the Fibonacci sequence is majorly famous, but the bigger point is that we can generate sequences recursively using the previous terms of the sequence. So you'll get some practice with this, certainly in the homework.